Hello everyone, welcome back. My name is Akal, instructor at Akalcom Networks. I'm so excited to be teaching you networking configurations. So in this lab, we will look at link aggregation, MSTP, DHCP, VRRP, and OSPF. And finally, we will get to configure the firewall where we'll implement security policy, NAT policy, and also configure the NAT server to allow PC on this intranet to be able to access our server. As we always know that to implement security, the servers are always implemented on the DMZ zone, so that in case somebody want to visit our network from an untrust zone, they will first get to the DMZ is when they are allowed to get into our intranet. So intranet users here will be able to access the server from the trust zone to the DMZ. So if you've been following my videos and you've been enjoying the session, remember to give me a thumb up. And also, if you are new to the channel and you find this information so resourceful, remember to subscribe to help support our channel. Under this lab, the interfaces, I have given them IP addresses, as that one is now helped to save time. The only part that I'm going to show you is now how do we configure this interface on a switch to enable it to communicate with the interface on the router. Gig 0/0/1 is on .1, while gig 0/0/1 is on .2. So we are going to enter to that switch. Let's first of all undo terminal, give that switch a name. So we are going to tell it switch number 1. First of all, let's create the VLAN. So we have got two VLANs, that is VLAN 2 and 3. VLAN batch 2 and 3. Then to be able now to establish a layer 3, now enter interface VLAN if 1 is what will enable the interface to able to reach router number 1. So we give it VLAN 1. Then give it IP address of 10.0.0.2, the mask of 24. Because the router already had an IP address, let's start to ping its interface. So 10.0.0.1. You can see it's able now to ping that interface of the router here, because now they are on the same network. We also again come to this our switch number 2 and do terminal monitor, UTM. Give that switch a name, so this name, here we tell it switch number 2. Then we create the VLAN, so VLAN batch 223, and now enter interface VLAN if 1 to be able to communicate with the router. IP address will be 10.0.1.2, the mask of 24. Let's ping the interface on the router. So ping 10.0.1.1. See, it's now able to ping it. After setting up the IP addresses, so that one I was just showing how you can configure this IP address to link with the IP address of the router. Now here are now the steps that we are going to configure. So step number 1, configure link aggregation. So link aggregation we are going to implement between switch 1 and switch 2. And the mode here we've been told to use LSCP mode. Mostly this lab will now help to implement what is called reliability, because this router here and this router are the gateway for the downer network. But now suppose this router number 1 goes down, router number 2 should be able to take over the role of router number 1. That's why we are going to implement a VRRP. Also, we are supposed to set DHCP server, 2 DHCP server. The first DHCP server is on router number 1, then the second DHCP server is router number 2. So in case router number 1 goes down, router number 2 will now still be able to assign IP addresses to the downward devices. The next we will implement MSTP. To begin, we will now create this switch number 1 as the LSCP active device. So say LSCP priority here, we're going to give it a priority of 100, the active device. Now we enter interface eth trunk 1. After enter the interface eth trunk 1, the mode here we said we are using LSCP static. Then we are going to set the number of maximum active interfaces, so maximum active link number will be 2, then least active link number we set to 2. After that, we will set the load balance mode here. We'll set it to SRC source IP. Then we are going to enter LSCP enable preemption. Then LSCP preemption delay will be 20. Display this. Then we are going to set the link type, port link type. We are going to tell this is a trunk. Then port trunk, allow pass VLAN 223. Then we are going to add the interfaces into the trunk. Now we are going to trunk port gigabit 0/0/4 to 0/0/6. That's the range of the interface that we are supposed to add into our ETH trunk. Come to switch number 2. The same configuration on switch 1 should be also the same configuration on switch number on the ETH trunk of switch number 2. So quit, enter ETH trunk interface, ETH trunk 1. Mode here will be LSCP static. Then the maximum number of active interfaces will be, maximum number of active interface will be 2. Then least number of active interfaces should also be 2. Load balance mode here, SRC source IP. Set the preemption mode, LSCP preempt enable, then LSCP preempt delay here we set to 20. Then enable it to be a trunk port, so port link type trunk port trunk, allow pass VLAN 2 and 3. Then add the interfaces into the ETH trunk, so trunk port gigabit 0/0/4 all the way to 0/0/6. Now we come and display ETH trunk. So display ETH trunk 1. When you display ETH trunk 1 here, you can see now gig 0/0/4 and gig 0/0/5 have been selected. So we said the maximum number of active interface should be 2. Then while gig 6 is unselected. So in case one of these two goes down, gig number 6 will now shift to active, will now be selected to take over the role of the interface that has gone down. So we are done with the ETH trunk. Now quit and save your configuration. So being done with step number 1, that was configuring link aggregation. Now we go to configuring MSTP. MSTP is supposed to eliminate loops on these 4 switches here, because these links implement what is called redundancy. When you implement redundancy, there's a problem that comes with the redundancy that is called loops. Packets will be forwarded just within our network and endlessly. So now to cap that, we implement what is called multiple spanning tree protocol. So we're going to implement MSTP on this our 4 switches. So we know as Huawei switches, MSTP is the default, so we don't need even to configure the mode as MSTP. So here what we're going to do is now to create the region configuration. So we're going to create the STP region configuration here. Then we can give it a name. So region name here, a name of R1. Then we can give it a revision level here, level 1. Then add the instances. So instance 1, give it VLAN 2. Instance 2, give it VLAN 3. Then tell it active region configuration for that configurations to take effect. Active region configuration. Quit now, because switch 1 is going to be the active for instance 1. So tell STP instance 1 root primary. Then STP instance 2 root secondary. Come to switch number 2 here, quit and tell it STP region configuration here, region name, here we said R1, revision level, we use level 1, instance 1, VLAN 2, instance 2, VLAN 3, then tell it active region configuration, quit, and for switch number 2, instance 2 is going to be the root primary, so instance number 1, STP, instance number 1 will be root secondary, then STP instance number 2 here will be root primary. We quit and we are supposed to implement MSTP on all the switches, UTM. So we are going to give this switch a name of switch number 3. So after that, we're going to create, first of all, create a VLAN batch 2 and 3. After creating a VLAN batch, create STP region configuration here. Region name here we'll use R1. Revision level here will be level 1. Instance 1. VLAN is number 2. Instance 2. VLAN is number 3. Then tell it active region configuration. Come to switch number 4 here, UTM. Give it a name of switch number 4. Create the VLANs, so VLAN batch 2 and 3, STP region configuration here, revision level, region name here will be R1, revision level will be level 1, then instance 1, VLAN 2, instance 2, VLAN 3. So now we are going to display MSTP to verify our MSTP configuration. So display STP brief. So you can see here gig 1 is designated and it is forwarding. Gig 2 is alternate and the trunk is the root. Now we are done with step number 2, that was MSTP configuration to recap loops. Now we are on step number 3. Step number 3 was now configuring the DHCP server on router here. So enter the router and configure the DHCP server. First of all, let's do terminal. So first of all, enable DHCP on the global view. After enable DHCP on the global view, we're going to create the DHCP pool. So IP pool. Here we are going to use VLAN 2 as the name. So the network here will be, network for pool 2 will be 172.16.2.0. Tell it mask. Mask here will be 24. Gateway list will be 172.16.2.254. This one will be the gateway, but this gateway will be the VRRP that we'll configure later. Then we are going to exclude some IP addresses from a range 100 to 253. So these are the IP addresses will be assigned for pool for router number 2 and also for the VLAN if interfaces. So exclude IP address 172.16.2.100 all the way to 172.16.2.253. Those one are the IP address that will be excluded. So display this. We set now that one. Now quit and create the pool for VLAN if 3. So IP pool VLAN 3 as the name. Tell it network of 172.16.3.0. Mask here will be 24. Gateway list here will be 172.16.3.254. That will be for the VRRP. Then we're going to exclude the address from 100 to 253. Exclude 172.16.3.100 to 172.16.3.253. We are done. We quit. Then we are going to enable the interface gig 0/0/1 to select global. So interface gig 0/0/1. Let's display if it has IP address, display this. So I tell it to it's already have an IP address. So we are going to tell it to assign the IP address for from the pool. So DHCP select global. Having that one will be now on router number 1. So in case router number 1 goes down, we are supposed also to configure DHCP server 2 for the backup DHCP. So enable DHCP on the global view. Enter IP pool name. IP pool here will be VLAN 2. Network here is 172.16.2.0. Mask of 24. Then we are going to give it a gateway list. Here will be 172.16.2.254. We are going to exclude some IP addresses. So the IP addresses that were assigned for pool number 1 on DHCP server 1, that was from 1 to 99. Those one were the IP address we are going to exclude. Those we are going to exclude from 100 to 105. That will be assigned to the devices. Exclude IP address 172.16.2.100 .1 all the way to 172.16.2.105. So from 1 to 99 will be excluded for server 1. Then from 100 to 105 will be for assigning to the devices. Quit and create IP pool. IP pool name here, we'll give it VLAN 3. Network, we have network of 172.16.3.0. Mask here will be 24. Gateway list 172.16.3.254. Excluded address here will be 172.16.3.1 all the way to 172.16.3.105. Now we've set the IP addresses. Now for these PCs now to be able to obtain that IP address, we need to configure what is called the DHCP relay, the DHCP relay agent. Now when this PC tries to send the discovery to discover where the server is, DHCP server is, the relay switch here will now help us to reach where the DHCP server is. So this one is just to relay the information of the client to the DHCP server. So telling the client where they can find the DHCP server. So we're going to enter that switch. So DHCP, enable DHCP on the global view. So we enable DHCP. Then we're going to create those interfaces. So first of all, enter interface VLAN 2. Give it IP address of 172.16.2 100. So this one, the IP address that we were excluding, /24. Enter VLAN if 3, IP address of 172.168.3.100 you quit, and we are going to create the relay agent. So after we enable the DHCP, we are going now to set the relay group. So DHCP server group here, we're going to give it a group of group. Let's give it group 1. It's actually created a DHCP group. Now we're going to give it a DHCP server IP. Here will be the IP of the server will be now. The IP of the server is the IP of the router number 1, that is 10.0.0.0.1. After that, we are going to now enter a VLAN if interfaces and enable the DHCP relay. So quit and enter interface VLAN if 2, tell it DHCP select relay, then DHCP relays select server select server was group 1. Also enter interface for VLAN if 3, tell it DHCP select relay, then DHCP relay here to select server for the group we created, that's group 1. The same should also happen to this other switch. DHCP enable interface VLAN if 2, give it IP address and do TM interface VLAN if 2. IP address here will be 172.16.2.101/24. Enter for VLAN if 3. IP address here will be 172.16.3.4, not .4, .3.101/24. Quit and select DHCP server group. Here we are going to create group 1, then tell it DHCP server IP will be 10.0.1.1. Quit and enter interface VLAN if 2, select DHCP select relay, then DHCP relay here to server to select the server. Here we said group 1. The same should happen to VLAN if 3, should relay the information for group 1. Let's see now if the PCs are able to obtain IPs. So we're going to select the DHCP mode, then apply. After that, come to your IP config to check if it can obtain IP address. Not yet. Display DHCP statistics. No requests have been made. Interface big0/0/1. Display this. We didn't enable DHCP, so DHCP select here is a global. Display DHCP statistics. So here there's discovery 85 have been made. So 85 discovery have been made. So let's see if this guy can try and find the IP address. IP config. So when we try to obtain an IP address on this, we can't obtain an IP address. Why? Because these links are down. The link from the switches are down. We are supposed to configure these links to allow VLAN 2 and 3 to pass. So we're going to enter UTM. So now to configure the port link type, you are going to group them like port group here will be group number gigabit 0/0/2 to gigabit 0/0/3. Here port link type trunk, then tell it port trunk, allow pass VLAN 2 and 3. Come to this other switch, we're going to enter gig 1 and this one to allow trunk port. Port group here, we're going to give it a group of number of gigabit 0/0/1 to gigabit 0/0/2. Tell it port link type here, going to be a trunk port, then port trunk, allow pass VLAN 2 and 3. Come do the same to switch number 2, number 4. Port group here, group number will be gigabit 0/0/1 to gigabit 0/0/2. Port link type trunk, then tell it port trunk, allow pass VLAN 2 and 3. Come to switch 2 here, port group number will be gigabit 0/0/0/2 to gigabit 0/0/3. Port link type is trunk, and port trunk, allow pass VLAN 2 and 3. We're going back to switches number 3 and 4 to configure the interface that connect to the terminal as the access port. Control Z and do terminal. Interface Ethernet 0/0/1. Tell it port link type. Port link type here is access port. Then port default. VLAN here will be VLAN 2. Enter for Ethernet 2. Port link type here will be access. Then port default VLAN will be VLAN 3. Come to this switch, enter quit. Interface Ethernet 0/0/1. Port link type access, then tell it port access. Port default VLAN here will be VLAN 2. Because now we've brought the interfaces up, now let's see if we are now able to obtain an IP address. You see now we can now obtain an IP address because now the links are now up. So here this PC was able to obtain an IP address of 172.16.2.253. Let's come and enable DHCP and try to find the IP address. So also able obtaining IP address of 16.3.2, meaning that has been assigned by router number 2. Display DHCP statistics. 239 discovery message have been made. 1 request have been made. Display DHCP statistics. You can see here 2 requests have been made on this one, while this one discovery message have been sent. So meaning that our DHCP now has been implemented, and also these 2 switches are able to relay the information of the DHCP server to the clients. So the next thing is now to configure OSPF to link these routes here. So we're going to configure OSPF on the interface that connect to the downer interfaces. So TM on configuring OSPF, what we do, OSPF process number 1, we enable them on area 0, a network of 10.0.0.0, webcasts of 0.0.0.255. Then another network where the pieces belong will be 172.16.2.0, wildcard mask of 0.0.0.255. Then a network of 172.16.3.0, the wildcard mask of 0.0.0.255. Come to switch here and also quit OSPF 1. Area is 0. Network, here we have got 10.0.0.0, mask of 0.0.0.255. So TM, allow terminal mounted so that we'll be able to see those packets. OSPF 1, area here will be 0. Display this. We have got that network, then a network of 172.16.2.0, the mask of 0.0.0.255. Enter for the network of 172.16.3.0, mask of 0.0.0.255. Display OSPF peer. When display OSPF peer, here you can see the neighbor state is full, and also the neighbor address will be 110.0.2.1. So we come to this switch here, enter OSPF process number 1, area here, area 0. That's the network of 172.16.2.0, mask of 0.0.0.255. See the LSS being exchanged. Then enter the network of 172.16.3.0, mask of 0.0.255. The neighbor state is now full. Then enter the network that connect to the router. So network of 10.0.1.0, the mask of 0.0.0.255. So we are now going to router and establish a peer with a switch. OSPF here will be 1, area here will be area 0, network here will be 10.0.1.0 with the mask of 0.0.0.255. Neighbor state is full. Then a network of 172.16.2.0, the mask of 0.0.0.255. Enter the network of 172.168.3.0, the mask of 0.0.0.255. So display OSPF peer brief. So it has established a peer with that one. The next thing we are going to do is now to configure the VRRP. After configuring the OSPF to work on our internet here, we're now going to configure VRRP on this router to implement redundancy. So quit and undo terminal so that those OSPF packets messages don't keep picking up. So on this router, we are going to create a sub interface. That is where we are going to create the VRRP interface gig 0/0/1.2. Yeah, 2 here will be its VLAN, that is VLAN 2. Then we tell it do .1 queue termination. We want to terminate VLAN ID of 2. Then allow ARP broadcast enable. After that, configure VRRP. It's going to be the active one, so VRRP, VRRID 2 here, virtual IP here, we're going to use 172.16.2.254. It is going to act as the gateway for our IP pool. I want to show you something here. Come back to your PC here. You can see now its gateway is 172.16.2.254. That will be for the VRRP. So if Control C, if we try to ping its gateway, will it be able to reach its gateway? It's telling destination unreachable because it doesn't know where that gateway is. So we want to configure VRRP for it to be able to see that gateway. So we say VRRID 2 here. Priority, we give it a priority of 113. Then we can tell it to preempt. So VRID 2 preemption mode timer delay set to 20. Then we can tell it to track the interface that connects to the firewall. VRRID 2 here, track interface gig 0/0/0. Then we reduce it to 50. Create another interface for gig 0/0/1.3.1 queue termination. The ID here will be 3. ARP broadcast enable. Then VRID 3 virtual IP here will be 172.16.3.254. That will be the gateway for pool for VLAN 3. Here we don't have to mention it as active because it will act as the backup. You can just tell it to track the interface. So VRRID, VRIP number 3, tell it to track interface gig 0/0/0. Come to the router which it's going to establish the redundancy. So quit. Then another thing that we are supposed to do here is that on that interface, on those interfaces, we are supposed to give them IP addresses. The sub-VLAN interfaces, we are supposed to give them IP address of 172.16.2.102/24. Display this. Then enter for gig.3. IP address here will be 172.16.3.102/24. On this router number 2 here, we are going to enter interface gig 0/0/1.2. IP address will be 172.16.2.103/24. Then tell it .1 queue termination. VID here we done 2. So this side we are going to just give it VRIP VRID of 2. Then the virtual IP here was 172.16.2.254. Or we can tell it to track that interface up. So VRID 2 to track the interface gig 0/0/0. Quit and enter interface gig 0/0/1.3. IP address here will be 172.16.2.102/24. 3.103/24.1q termination. The ID here will be number 3. Then let's go back to VLAN 2. Display this. We didn't enable ARP broadcast, so tell it ARP broadcast enable. Then enter 3. Let's display this. So tell it ARP broadcast enable. Then configure VRRP, VRID. On this side, VRID 2 will act as the active one, so VRID 3 virtual IP here will be 172.16.3.254. Then VRID as the priority 3, we give it a priority of 130 for it to act as the active on switch 2. Then VRID 3 here, we are going to tell the preemption mode here, timer delay we set to 20. Then I'm going to tell it to track the interface. So VRID 3, tell it to track interface gig 0/0/0, reduced it to 50, quit. Now we need to verify our VRRP. So quit display VRRP brief. Here you can see here it is still initializing, meaning that master is 0, backup is 0. So in a situation where it can't identify itself as master, meaning that all of them are inactive, they are non-active. So we are going to enter the sub interface and enable .1 on that interface for the VRRP. So interface gig 0/0/1.2. You're going to tell it .1q termination VRID, VRRP, VRID here we're going to give it 2. Also enter for 103.3. Tell it VRRID here will be .1q VRRP VRRID 3. Also come to router number 2. So interface gig 0/0/1.2.1q termination VRRP VRID 2. Enter for 103 VRRP VRID 3. Now let's check if it's able to establish master and the backup. You can see here it has changed to the backup. So for VRID 2 is the master, then VRID 3 is the backup. Now that we've configured VRRP, which is going to act as the gateway for the DHCP pools for these two DHCPs, we were not able to find that gateway. Now let's see if now we can ping that gateway from our PC. Ping. You can see now it's able now to find that gateway. Initially it was telling us that destination was unreachable. So we are now able to reach this gateway, meaning that now the VRRP is now active. Let's see on this other PC. So IP config has an IP address of .90. So we're going to ping its gateway. Ping. See, now it's able to reach its gateway on this PC number 3. ipconfig. Let's try and ping our gateway. Control C. Ping. It's able to reach now. Can now PC1 and PC2 communicate now that we configured the OSPF? We are going to copy the address of this PC, that is 172.16.3.9, and come to PC number 1 and ping that. It's able to reach that one because of the OSPF. So we've implemented these 5 steps, that is step number 1 up to number 5. The only step that remains will be now step number 6. Step number 6 that we are going to configure in our next lab. So we are going to post this lab at this point. Then in our next, we are now going to configure the firewall and to enable the security zones, and also configure the security policy and the NAT policy. And also in that next lab, we will implement another part that is called the WLAN. We're going to improve our network. We are going to increase devices so that we also implement wireless communication in our network. So that one is for the lab that will follow after this lab. So I'll prepare a video tutorial that discusses that, so that now PC1 here should be able to visit the server from the trust zone to the DMZ zone. So thank you for watching the video. Remember to stay tuned for the next tutorial that will follow this. That will be the module 2 of this lab, that is the enterprise network. So thank you very much, and let's meet in this next class.